Okay, so I didn't get a chance to record this during class today because the internet wasn't working great, um, and I forgot to do it after class. So I'm going to do it now, and I'll post it as soon as I can. It's about 6:30 p.m. at night. So if you didn't get a chance to get this done, that's okay. Just hold off and turn it in on Friday after class. Fine. But what we're talking about today is ions and isotopes. So the other day we talked about how to find the number of protons, neutrons, electrons in an atom from looking at the periodic table. So if we look at an element on the periodic table, we'll see a number on the top. We call that the atomic number. Okay. Then we'll see the symbol. It starts with a capital letter, and then all subsequent letters are lowercase. Always make sure it starts with a capital, and then all lowercase after that. That's really, really important. Okay. And then you'll have the name usually. And at the bottom, you'll either have mass number or atomic mass. We'll talk about what atomic mass is actually on Friday or tomorrow. But right now, we're just going to be dealing with mass number. And mass number is simply the number of protons plus the number of neutrons. Because if you recall, protons weigh 1 AMU and neutrons weigh 1 AMU. And electrons are 1/2000th of that. So we don't even really count them in the mass. We only count protons and neutrons in the mass when we're calculating the mass of an atom. Okay, so yesterday we looked and we saw that the number of protons is simply equal number of to the atomic number. So the atomic number will always tell you what the number of protons are. If you don't know the atomic number, but you do know the symbol, you can figure out the atomic number because germanium always has 32 protons. Okay. And what we did yesterday was kind of a little bit of like a puzzle. Sometimes you get the element name, sometimes you get the atomic number, sometimes you get the mass number along with protons or mass number along with the name. And then you have to fill in all the other information based on that. So it's kind of like a little bit of a puzzle, a little bit of critical thinking there. All right, and we're going to be doing a little bit of critical thinking today as well, okay, when we talk about ions and isotopes. Okay, so to continue on here, so atomic number is simply the number of protons. That's always, always, always the same. And yesterday we said that electrons are equal to number of protons. Okay, and this is true in a neutral atom. Okay, if the atom has no charge to it, then that is true. The electrons equal number of protons. But what we're going to be looking at today, ions do not have the same number of electrons and protons. They're different. Okay, so electrons and protons are sometimes different, and we'll have to look at the charge on the atom to figure out how many electrons something has. Okay, and then finally the neutrons. Neutrons is simply the mass number minus the atomic number. So mass number, because that's protons plus neutrons, right? Protons plus neutrons. And then the atomic number is simply minus the protons. So you're subtracting protons. So if you subtract protons from this, you get the number of neutrons. So that's why it's mass number minus atomic number gives you number of neutrons. Okay, so that's everything we talked about the other day. Hopefully you're able to do that. If you're still having trouble with that, stay after class with me and we can talk about it and we can figure it out. Okay, that's really important that you know how to do that before you know how to do what we're going to be talking about today. And today we're going to be talking about ions and isotopes. So ions are atoms that have unequal amounts of electrons and protons. Okay, a charged atom that has unequal amounts of electrons and protons. Surely I should say protons at the end here. Okay. All right, and we'll talk about what a cation is, positively charged, and an anion, negatively charged, and why they are that way. Okay, and then we'll talk about isotopes. And isotopes are two or more atoms, I should say, with the same number of protons but different numbers of neutrons. Now, the number of protons stays the same for every given element, but neutrons can change. For example, hydrogen can have just one proton. Hydrogen can have a proton and a neutron, or hydrogen can have a proton and two neutrons. So it can weigh either 1 AMU, 2 AMU, or 3 AMU. So its mass is different. Okay, these are all still hydrogen. They're all hydrogen, but they're all isotopes of one another. Okay, and these isotopes actually have names to them. Usually isotopes don't have names, but these ones are very special. So they do have names to them: hydrogen, deuterium, and tritium. Okay, but we're not going to be worried about the names, just anyway. Okay, so let's look first
quickly, let's look more in depth at ions here. So ions, again, are charged atoms with unequal number of electrons and protons. And there, I didn't forget it there. I wrote n protons there. Okay, so if we have a neutral atom, so atom that has equal number of electrons and protons, so their positive charges and negative charges are equal to each other, so there is no charge overall. That's why we call it neutral. Okay, no charge overall. However, if we lose an electron, so atoms will lose or gain electrons, to become more stable. They also do it when they're bonding with other atoms. Okay, so they lose or gain electrons in order to become more stable. Okay, and we'll talk about that when we talk about bonding. We'll talk about the octet rule. Okay, the octet rule and why atoms lose or gain electrons. Okay, but just know for now that atoms can lose or gain electrons. If they lose electrons, that means they have less negative charges and more positive charges. So loss of electron creates cations. Okay, cations. Now, easy way to remember cations is there's a positive in the name, cat ion. There's a positive in the name. It tells us we have a positive ion. Okay. Also, we should know that cats are positive, right? Well, that looks like an evil cat. Cats are a little evil, but they are positive. They're awesome. So positive cats. Meow. There we go. Little kitty, little mean kitty. Okay, so cations, positive. Okay, positive in the name. Okay, examples of cations, so like sodium. Sodium, when it's neutral, it's not very stable, but it likes to give off an electron to other atoms, so it gives off an electron. And when it loses one electron, now it has an extra positive charge, so we call it Na plus. Okay, we can write it Na plus, we can write Na plus 1, or we can write Na 1 plus. It doesn't matter what order we write it in, 1 plus, plus 1, or plus, doesn't matter. Okay, calcium likes to give off 2 electrons. So calcium gives off 2 electrons. Likes to give 2 electrons to people, to other atoms, I should say. And it becomes a Ca2 plus, or Ca plus 2. Doesn't matter which way you write it. Okay, so it gives off electrons, therefore it has more protons than electrons, and it has a positive charge. Okay. Now, if we gain electrons, so some atoms like to gain electrons. Okay, if we gain electrons, now we're going to have a negative charge. We're going to have extra negative charges. We're going to have more negatives than positives. So therefore, we get a negative ion. I can remember that by anti. Anti is like against or negative, right? Anti, negative. So anti usually means negative or against, right? It's the opposite. So negative is kind of the opposite. Okay, anti-anion. Anion. Okay, an example of an anion, chlorine. It likes to absorb an electron. And when it absorbs an electron, it becomes Cl minus, or Cl minus 1, or Cl1 minus. Write it any of those ways. Okay, oxygen. Oxygen likes to take on 2 electrons. So 1 electron, 2 electrons. Bam, bam. And it becomes O minus 2, or O2 minus. Okay? So that's anions and cations. All right, so now if we want to figure out how many protons, neutrons, and protons and electrons, really, neutrons aren't going to change here. We have to look at the charge on the ion in the periodic table. So here, beryllium, it says it has 4 protons, but it has a positive 2 charge. So that means it has 2 more protons than electrons. Okay, but we cannot add protons. We can only take away electrons. Okay, so if we have 2 more protons than electrons, that must mean we have 2 electrons. Okay, because we have 2 more protons than electrons. 2 more. Okay, the next one, we know we have 16 protons. If we look at the periodic table, so we go up here to the periodic table, which element has 16? Oh, all over the place here. The element that has 16 is sulfur. Sulfur has 16. So we have sulfur. That's the symbol. Okay, sulfur is the symbol. And then we have 16 protons, 18 electrons. So we have 2 more negative charges, 2 more electrons than protons. So therefore, this must have a -2 charge. 2 more negative charges than positive charges will give an overall charge of -2. Okay, next one, vanadium. So vanadium, if you look at the periodic table over here, vanadium has 23 protons. That's the atomic number of it, 23. Oop, I didn't want to mess with you. Go away. So vanadium has, I just forgot it. I forgot what it's at. 23. So its atomic number is 23. Come back down. Come on. Okay, so vanadium is 23. Okay. And then if it's a +3, that means we have 3 more protons than electrons. Again, we can't add protons, can't take away protons. So it has to have 20 electrons. Okay, 20 electrons, 23 protons. That's 3 more positives than negatives. So it's 20 electrons. Okay, next one, iodine. So iodine here has the atomic number of 53. See that? 53 there. So that means it has 53 protons. That never changes, 53. That's one thing that's always going to stay the same number of protons, okay? Then we know it has a -1 charge, so it has 1 more electron than protons. So we add 1 electron here, so it's 54. Okay, and then finally selenium. Again, got to look at the periodic table here. And selenium has 34 protons. Very nice, 34 protons. So 34. And this one has a -2 charge. If it has a -2 charge, that means it has 2 more electrons than protons. So we got to add 2 electrons here. So it's 36. Okay, so that's ions. That's ions for you. Okay. Next, isotopes. So isotopes are 2 or more atoms. They have the same number of protons, but different number of neutrons. So their mass is different. Mass is different. Okay, that's really what matters, is that the mass is different. Okay, so example of isotopes, carbon. Carbon has a bunch of different isotopes. It has one isotope that has 6 protons, 6 neutrons. So it has a mass of 12. It has another one that has 6 protons, 7 neutrons, so it has a mass of 13. Okay, then this one, carbon 14, has a mass of 14. It has 6 protons and 8 neutrons. Okay. Now, there's 2 ways to write these symbols. One is to write it in the upper left-hand corner. We write the mass number in the upper left-hand corner. Okay. That's one way to write it. And then the other way to write it is the name of the element, and then a dash, and then the mass of the element. Okay. Typically, you see this one, the dash one, when you're writing like in a paper or something like that, or in a sentence. And then you'll see these ones when you're actually writing the symbols for it. This is kind of the symbol. This is kind of the word. Okay. Okay, so there's 2 different ways of writing the notation there. Okay, and usually I'll specify which one I want you to write. Okay, and I'll give an example. I'll say use the shorthand notation or the long notation, and I'll show you an example of it. Okay, so again, these numbers represent the mass. Okay, so you may even see it like this. Sometimes see 12 and then 6 here. The larger number, that's always the mass number, and this is the atomic number. And sometimes you'll see it called the Z. The atomic number, the abbreviation for it is Z. Z is the atomic number. Okay, so let's look at some of these over here. Right here. Here we go. So for these ones, we got to look up the number of protons, and then from there we can figure out the number of neutrons. Okay, I'm going to pull this actually down so we don't have to go so far. A little bit same size. Let's see if we can do it like that so we don't have to go back and forth so much. I think that's better. Yeah, much, much better. Okay, silicon is 14, so it's 14 protons. Okay, so if it has 14 protons, the mass is 29. So protons plus neutron has to equal the mass. So basically, you're taking the mass minus the protons, you get the neutrons. So 29 minus 14, you get 15. Super, super simple. Okay, nitrogen, 7 protons. 15 minus 7 is 8. 8 neutrons. Uranium, 236. If you go down to the bottom, it's 92. 92. 92. So 236 minus 92, 144. Chlorine, 17. Oh, sorry. Yeah, 17. 17 protons. 35 minus 17 is 18. Phosphorus, 15. 15 protons. 31 minus 15 is 16. Okay? So isotopes, just like that. Okay, now the last part here, I just want to look at one example here. I did make a mistake in one of these problems. I think this one right here. Sulfur in your sheet, I think this says 90. That's wrong. Fix that, make it 52. And then the answers here are 38, 90, 38, 38, 52. Okay. So let's look at how to do one of these. Okay, we'll look at 2 of these. So let's look at fluorine. So fluorine is a -1 charge. So first of all, fluorine will always one of the easiest things to start off with is just the atomic number is 9. Atomic number is 9. That means the number of protons is 9. Okay. Now it says if that's 19, that means the mass is 19. Okay, so the mass is 19. That's easy as well. Okay. And then we have the number of electrons. It's negative. So there must be one more electron than protons. So one more electron than protons, that makes it 10. So you must have 10 electrons, 9 protons, which gives us a -1 charge. Okay? And then we also know number of neutrons is 10 because the mass minus the protons or minus the atomic number gives us the number of neutrons. Okay, let's look at one writing the symbol. Okay, writing the symbol. So here we have atomic number 20. So the element that's atomic number 20, if we go down here, atomic number 20 is calcium, Ca. Okay, now just be aware, Ca, the mass number on the periodic table may not be the same as the mass number given here. Okay, so the mass number on the periodic table here says it's 40. That's just one isotope of calcium. There's other isotopes, and we're looking at isotope 41, so calcium 41. So you're going to write Ca and then 41 up here. Okay, then we also have to look, does it have a charge to it? Okay, does it have a charge to it? So if the atomic number is 20, that means we have 20 protons as well. But we only have 18 electrons. So that means we actually have 2 more protons than electrons. So this is a 2+ charge. Okay, 2+ charge. All right, so it's kind of a bit of a puzzle. Kind of a bit of you have to use some critical thinking here. Critical thinking, find the symbol sometimes find the electrons, neutrons. Have to know all the relationships between those so you can fill in all the blanks. Okay, so hopefully that helps. Hopefully you guys can do that. We'll be practicing more of that next week as well. So if you don't quite get it yet, make sure you do ask questions. There will be a quiz on this next week. So make sure you know how to do this. And I will see you all tomorrow.